Hey y'all, thanks for being here. We are doing the ADI Books Deeper Dive today in fourth grade. And I am here with Victor Sampson. I'm Krista Sampson. I will be moderating and Vic will be presenting. So I will hand it over to Vic.
Let's talk about the fourth grade books. So right now we just released two fourth grade books. One that was written for Texas that's aligned with the TEKS. I've got the table of contents for that one here on the right. So it includes physical science, earth space science, and life science investigations. And we also released one that is aligned with the NGSS, so each of the performance expectations as well as the table of contents is on the right again. As you can see, this one also has physical, life, and earth space science investigations. They're different than the ones that are in the Texas book because there's different alignment of standards. So kind of depending on where you're at is which book is best for you. So what I was thinking to do is go through one of the investigations from the NGSS book, just kind of step by step so you can kind of see how it works and get that kind of deeper dive going on. So we're going to do one called Storm Drains Clogged with Debris for this one. So to kick that off, what you can do is hand students out this handout. And this is the task stage handout. And your goal for this is to do kind of three things. One is to introduce a phenomenon. I'll show you what that looks like in a second. And then once you introduce that phenomenon, you elicit students' ideas about it. After they're sharing their ideas, you move that then into the task, which will be around one of their ideas about storm drains getting clogged with debris. Then you give the students a chance to create a model or share their ideas about why they think the drains get clogged so frequently, and then have a chance to share those ideas with each other and then generate some more questions they would like to answer about that. So let me show you how that looks here. One of the nice things about that comes with each of the books is a free teacher account in the Learning Hub. And so when you get to the Learning Hub, you can go into there, you can find this investigation in it, click on the presentation mode, and it'll bring up these slides, which act as a kind of a guidance slide deck for you. So this is for the task stage, the activity called the phenomenon. So you click on that and then it brings this up and you can show this on the screen and help guide students through this. So let me show you what the video looks like for this investigation.
Well, some people are working to move their stranded cars, others, like this man, trying to clear clogged drains. So you can see he's using a rake there to move the debris out of the way.
The city of Spokane appreciates your help as long as you can do that safely. Credit to Amanda Rowley spoke with city leaders to find out more about the cleanup effort now.
This intersection here at Francis and Canyon in North Spokane is a very different scene from what we saw last night. Here at this intersection, there was major flooding that caused multiple cars to get stuck in a lot of water here. And now the water is, for the most part, cleared away and the drains are draining normally. But we did see some residents here yesterday trying to clear debris away from the clogged drain. Spokane City officials say if that's okay, they welcome the help.
In most cases, especially on residential streets, it's safe for you to go out and just try to clear away the debris. All of those loose pine needles and the flowering trees, all that stuff got knocked off the trees yesterday and did cause some clogging of drains. So as much as people can get out there and remove that, that helps the wastewater system.
City spokesperson Marlene Feist says while clearing the drains helps, it's also important to make sure you're safe by being aware of traffic.
But, you really want to be paying attention to cars. You don't want anybody to get hit in that situation.
City crews are out working to clean up debris and fix any clogged drains the flooding caused last night.
We put the reference sign right here.
In fact, cleanup on 5th and Walnut closed off access to the I-90 on-ramp for most of the day today. City officials say, though, it's expected to reopen by the evening commute. Feist says city crews do routine checks to ensure the drains are working properly.
Certainly there are places that they are aware of that more frequently get clogged, and they go out and they clear those. We do that in the winter time too. They have those big vac trucks that can take care of lots of problems. And also yesterday they were just out with shovels clearing storm drains just like anybody else.
Amanda Rowley, Front 2 News.
So you show them that video, and then you can click onto the next slide here and you write down some things you notice. And what they'll talk a lot about is a lot of the cleanup of the debris. And then that moves right into the task of this is like, where does that come from? Why do those drains get so clogged? What's causing that? Once they kind of generate their ideas about how that's happened, they're going to have a lot more questions. So then we introduce some science ideas to help them put some pieces of the puzzle together. So here's the handout for the ideas stage. And what we would first do is talk a little bit about rainwater drainage, right? So like when it rains, where does the water go and how do we end up getting kind of these clogged or what a clogged drain looks like. So in this case, we'll talk about the difference between a sanitary sewer and a stormwater drainage, right? So those are two different systems that move water out of there. And then showing them a picture of what something looks like, how a drain can be very clogged and prevent water from moving. And once it's moved away, then you can have water moving again. So what I usually do with this is I'll read this aloud for students as they follow along. And then I have students talking in groups of like, what would be useful, what would be interesting from about that, that can help us answer those guiding questions. The kids then share out those ideas, and then we can put a kind of a class list together. In addition there, then we move on to like, we can start talking about properties of water then, is the second idea we talk about, especially the idea that objects can sink, float, or stay suspended in water. And then we finally introduce the idea of using models to investigate cause and effect relationships. So you can build a model of a storm drain during a rainstorm, and then you can use that to test different ideas that you have. So once again, you read through all of these and get kids to kind of identify the ideas that are going to be most useful for figuring out the guiding question of the investigation. We also have in Learning Hub, when you're using presentation mode, you can project all of this text up on the board, and then you can click on the pictures and make them larger, which is really nice because they'll be in full color. Often when we have handouts, they're only black and white, so it makes it a little bit easier for kids to see things when the copies aren't always the best in the whole world. You can see an example of what that looks like here. You can see the pictures nice, big and bright. You can actually click on them again and make them even bigger and they go full screen. So it's kind of a cool feature that makes it a lot easier to kind of share these ideas and read through these different texts. From there, what you do is we already introduced the idea of using a physical model to explore a cause and effect relationship of like what was causing the storm drains to get clogged with debris. So what you can do at this point is show them the physical materials that they have for making these models. So what we usually recommend doing is putting these out on a table and then kind of going through them one at a time and asking what they could possibly use them for. The nice thing we also have with each of our kits or each of our books, each investigation, you can get a kit for these, so you don't have to source any of these materials. It just comes with everything you need. It's for your class, and you can get those on our website pretty easy. Once you have a chance to show them what equipment you can use, have the students work in their groups to come up with a plan. So here's the handout for their investigation plan. It's basically a graphic organizer that encourages kids to think about what question they're going to answer, what data they're going to collect in terms of observations or measurements, how they're going to do that. Show me a picture of how you're going to set up your equipment, and then how you're going to analyze the observations and measurements that you collect. Kids come with this plan, you can go over and check it over real quick, give them some feedback, and if you think it'll be productive, sign off and let them get started. Then they can go ahead and set up this equipment and be ready to go. So as they're then using their equipment and collecting data, they have a spot on their handouts where they can write down the things that they noticed, maybe how much debris moves, how much water they were pouring, anything they were testing, those ideas. Sometimes they make a table to keep track of stuff. Sometimes they don't. It's really just a space to keep track of anything that they think is important. Then on the next page, they give a chance, then they're encouraged to actually make sense or analyze their data. So that in that place, they can start making comparisons or show trends, and they can do different pictures or graphs or make a table here. There's all sorts of things that they can do to kind of decide on how do you tell a difference between something or a trend over time or a relationship. So there's that space to do that. We always include a grid there, not just because they have to make a graph, but it just gives them the option to do that. At the end of that stage, they should have an answer to the question, which is, why do these drains become clogged? So with debris. So what we want each group then is to generate or create an argument that they can use to share what they figured out. We have students do these on whiteboards. And then we ask them to put 4 things on there. What's their the question they're trying to answer, their claim, which is their answer to that, the evidence that they have support of that. So that's the observations or measurements they collected and then made sense of. And then the justification is their evidence is the ideas that they're pulling from that they were introduced earlier, that tells them why their evidence is important. So in this case, they would be talking about how they can use models to represent bigger things that are really hard to test on, right? So like it's really hard to go outside and test something on a big storm drain, but you can develop a model to test your ideas instead. So you can talk about that as a way to justify the data that they collected with the model is appropriate for answering the guiding question for something that's not a model. To help them develop those arguments, we also have in Learning Hub these extra supports that you can show. So in this case, that you can add some extra hints for students if they need them about what goes where into their arguments. After they're done making their arguments, we have them go ahead and share those with each other and give each other feedback. And there's a space on their handout there that they can use to write down ideas of ways to improve. Once they get back to their groups, they revise their argument and finalize it. So at this point, they should have a pretty solid understanding of the answer to the guiding question. So from there, what you want to do then is have a whole class discussion. And what you want to do is talk about the ideas they were using, not necessarily the answer to the guiding question, but the ideas they were using during the investigation, and also how to engage in the practices of science and engineering in more productive ways over time. So what we did is we add these prompts in the Learning Hub. So this is just on the reflect stage. You go to that stage, you can show this on the board and ask the groups to take a look at these pictures and then kind of try to discuss what they see happening based on what they know about the properties and movement of water, which they were using in this investigation to explain the kinds of things that they were seeing there. This is a great time that you can correct any misconceptions and make sure they've kind of got the main ideas of what they were needed to learn in this investigation. Then from there, you can go to having them talk about what practices that they engaged in and how they can do that more productively over time. We recommend just asking them these 3 simple questions. 1, what things did you do during your investigation and made it scientific? So what went well? What would you have done differently to make it more scientific? Like what if you had to start all over, how would that look? And then finally, as a class, what should we do the next time we carry on an investigation to make sure that we do the best job possible? And then you can generate these rules, you can put them up on the wall and remind students about them. And the idea behind doing this is kids are going to make mistakes, they're kids. But what we want to do is give them a chance to learn from those mistakes. So when they make them, fine, talk them over, and then they can plan for the future. And what ends up happening is they get really, really good at designing and planning and carrying out investigations and analyzing data because they've had these chances to see what can go wrong and then learn from them. And then it becomes part of their own ways of doing things. It's pretty cool to see. We also have on their handout a spot where they can record their own notes about that. So for example, if you're talking about the ideas part about like the properties of water, if you want to make sure that they remember something, or for an upcoming assessment or something like that, you can ask them to write that down in there. This is also where you can record kind of the class rules for investigations that they can refer to later. Then finally, the last step of the investigation is we have each student on their own write a report to share what they figured out. report is basically one piece of paper, 2 sides. It starts off with an introduction, which is what were they trying to figure out? What's your question? Then there's a method, what they do to answer that question. And then finally, there's an argument, which is what they learned. So that basically comes from the big whiteboard that they finalized, but now they're taking it and turning it into, instead of kind of bullets, then putting it into paragraph forms. And then they can also add a table or a graph or anything like that that they need to in that box. Once they make those, write those reports individually, you can collect them from all your students, and then you can have them peer reviewed. And how you do a peer review is we recommend putting them in groups of 2 or 3 in the younger grades. So we'll say groups of 2 for the right now. Say you have 24 students in your class, that would be 12 groups of 2. So you have 12 pairs in your room. You would give each pair a report written by somebody outside the pair and this peer review guide. Then you give them 15 minutes to, as a team, read over that report and answer these questions on there. And as they go through the questions, there's a spot that says reviewer rating. And if they say yes, that means they think they did it perfectly and it looks great. If they mark no or somewhat to that question, they need to go down to where it says reviewers and add some feedback about what they would change or how they can make it better. That takes about 15 minutes for them to go through one of these reports. You collect all of those from each of the pairs. Each pair gets another different report to review and a new peer review guide, and they do the process again. So what ends up happening is all 24 students in your class gets reviewed by a different pair of students, and each pair reviews 2 papers, so they get 2 opportunities to see some other people's work. And what's really nice about this is it really helps the writing a ton, because they're not only getting feedback, but they're discussing about what looks good and what counts as quality, and they start developing these kind of these shared norms for how that we're supposed to write and what do we mean by that. When each student gets their draft report back with their peer review, they can look over it and then they can write their final. You can give them another copy with sentence starters, have them do it on a blank piece of paper, have them type it, whatever you want to end up doing with that. But once they're done writing their final version, they can turn it back into you with the same peer review guide, and then you can use the column that says teacher score, and then use the same guide as a rubric to assess how well they did on that. So it's a really nice way to show them exactly what they're going to get scored on and gives them a chance to have the best product possible. And it's a nice authentic assessment of their learning that can go in the grade book. Now, as we're wrapping up here, that can be a lot of stuff. So I want to remind you that we include detailed lesson plans and everything. So this is the lesson plan for the storm drains clogged with debris. They include an overview of what the students are figuring out, what the guiding question is, a graphic that shows how you can break this investigation over multiple days. So we usually assume you've got about 20 or 25 minutes per day for science. That graphic will show you how to break that up and get done with everything you need to. We have all the standards laid out, not only science, but also English language arts and language development standards. We include a section that talks about the core ideas and the cross-cutting concepts and the science and engineering practices. These are all the things you'll be discussing in the reflection, so it's nice to have that there. We also include a detailed materials list and drawings about how you can set up everything, possible things that the students can test. Once again, with the materials list, you can source these yourself, or you can get a kit from our store that comes with everything you need for an entire class, which makes it really easy. And then finally, we have a detailed kind of notes for your teacher for each of the activities within a stage. So each of the 7 stages of ADI have multiple activities inside, so we break those down by activity. So this is for stage 1. So activity A and activity B of stage 1. So activity A is about 5 minutes. That's the phenomenon. It tells you how to group students, what to do, what to give out, what to show on the board or on your screen, some extra teaching tips, some ideas about attending to equity for students that need some extra help. And then you can move on to the next one. The idea behind this is not that you must follow this word for word, but it's kind of an example of how we would do it when we're teaching. So it can be a nice starting point for you, and then modify however you best see fit and make it better. So with that, we'll move to our section on questions. So if you have any questions, please hit the Q&A button.
We do have a question from Ethan, and he asks, are the passages differentiated?
So no, they are not. So what we do with ours, since it often when we're thinking about differentiation in text, it's usually done by scoring it in terms of lexile levels and things like that. That usually is broken down by complexity of words and complexity of sentences. So when you're reading about science stuff, you usually have multiple syllable words that bring the lexile level way up. So in some ways, changing the lexile level of the science passages makes it impossible to focus on the science. So what we do instead is we intentionally write these so they're very, very clear. So anytime there's any kind of terminology that's introduced, it's immediately defined as part of the text. We use images as a way to help explain any concept. And then we recommend what you do to help students comprehend more what they read, of the way that you can support them by kind of gradually releasing. So we'll talk about either reading it aloud and pointing out important things and then have students discuss them, or having them read and then annotate. There's all these tricks that we put in there for you. So what we want to do is give kids more opportunities to read these kinds of texts. And then as the more they do it, they get better and better. So we see this as a way to really help kids practice.
Awesome, thank you. I think that's it for questions. And do you have one more slide you wanted to share?
I do. If you're interested in looking at an investigation from the 5th grade book, we will be doing our deep dive into that in 5 minutes. We'll start at 5 o'clock, and that'll go to 5:30. So feel free to join us if you'd like.
All right, thanks all. Have a great evening.